Hello, and thank you for joining us on today's discussion, Transforming Your Business with Data and AI. I'm Michelle McLean, VP of Marketing here at ScaleArc, and I'm joined today by Ahmed Halawani, Cloud Solutions Architect with Microsoft. Ahmed, thank you so much for your time today.
No, thank you very much, Michelle, for having me here today.
All right, we are going to talk today about transforming your business with data and AI, and Ahmed is going to take us through capabilities built into SQL Server that will make it easier for your organization to get smart with data and leverage the insights from AI. So with that, Ahmed, go ahead and take it away.
Again, thank you again, Michelle, and maybe just a quick introduction for myself. So Ahmed Halawani, I'm a Cloud Solution Architect here with Microsoft working on the data AI side of the house. So in my current role, we definitely get ourselves into talking a lot about advanced analytics, data services, and the data space in general. So I wanted to outline this in today's session, give us a quick kind of overview into some of the ideas of where advanced analytics is making some changes and kind of the thought process behind that. Segueing into an intro, some of our data services that we have within our Azure framework, some of our SQL Server R capabilities, which have been discussed through this webinar series, and finally, a very, very brief demo, being respectful to the time that we have in today's session. So we talk about data analytics, but what does that really mean to us? So, we've identified three major trends in the industry. One being that data will grow by 44 zettabytes by the year of 2020. What does that really mean for us is that today 80% of the organizations are going to adopt a cloud-first strategy based around the fact that data will grow. Within that investment, we've seen a lot of changes within the way that the business do their structures, and there's been a significant increase into the advanced analytics and AI space. So being that AI investment will increase by 300% by the year 2017. Molding all of those three attributes together brings us data, AI, and into one kind of central landing zone being the cloud. Organizations that harness data, cloud, and AI outperform. So the outperforming, Microsoft positioned themselves with an IDC survey, and we interviewed over 2,000 organizations understanding some of their expectations in their big data landscape, and the result set was pretty startling. We identified that there was an additional potential business growth of $1.6 trillion. Now, within that type of assessment, we understood that ultimately the organizations are going to have to produce at least a 10% increase into building new and additional products leveraging some of their data assets into their business. Ultimately, they projected growth by 2020 is 1.6 trillion, 10% of that. So how do we get to that 1.6 trillion? So we've identified kind of four transforming key aspects of the business. So transforming your products. So when we talk about transforming your products, an example of that is Microsoft works with a elevator company, and this elevator company typically has been doing business a particular way, right, being able to manage their services. But because of them holding so much historical data set, they've transformed their business into now becoming a preventative maintenance provider. So that is one quick way that a company can leverage a lot of their data assets and move on to being a different type of data provider. Another aspect of this is engaging your customers. Sentiment analysis has become a very popular way of understanding what your customer engagements look like, whether that's through a retail shop or just engaging within your products. Another aspect of this is optimize your operations. So when we think about optimizing your operations, think of a good example would be a retailer that does logistic transportations for goods and services. Well, if those goods have a particular mandate that they need to be kept at a certain temperature range, what are ways that we can make sure that the goods arrive as they're expected? So refrigeration, getting good insights into the way that products get from A to B help us get to a better operational type of standard. And then moving to the fourth is empowering your employees. This ultimately is allowing your employees to build upon the tool sets they currently have. right? Being able to leverage skills, responsibilities that they currently have, but using a lot of those data assets. And that ultimately kind of builds into this key success criteria, merging all four together. System of intelligence essentially is what we get towards. So in identifying kind of those four different pillars, this is where this data dividend $1.6 trillion estimation came in. And it's estimated that within operations and productivity, being that operations optimizing the way that your current workflow enables your business to operate at a higher capacity. We gave that retail example, but then also going to productivity, right? Being able to give tools to allow your employees to succeed in building better types of products by leveraging data sets that they have internally, as well as leveraging a lot of tool set and skills that they already have within the industry. So what we did with part of this survey is we identified kind of 5 industry verticals where we found the most growth in regards to data analytics, as well as kind of data consumption, being your retail consumer products, government, manufacturing, healthcare. And something that's common amongst all these different vertices is the fact that massive amounts of historical data sets. So with massive amounts of data sets that they store, it kind of gets us to some kind of game-changing examples. So again, social media sentiment analysis being one of those examples, right? How are users engaging within your platform? What are things that you can do from an engagement perspective that you can tailor an experience to a particular end user? This is where a lot of the kind of recommendation engines are built. Pharma genomics, I think, is a very powerful new industry that's slowly starting to find its way into this, leveraging a lot of your historical data sets to do some genomic type of processing, gene sequencing, data, DNA type of gathering. So collecting all of this is great, right? But what does that ultimately mean for us from a data store perspective? So this is kind of introducing kind of our modern data state within Azure. Talking about our on-prem into our cloud type of distributions. So when we talk about different data stores, throughout this web series, we've talked about SQL Server and SQL Server capabilities. And it's important to note that, SQL Server, in the way that it's presented today, is kind of an all-in database, meaning that it is an industry leader, understanding that you're still going to get the performance that you are accustomed to, if not with the current improvements. But really where we start seeing a lot of the big growth is leveraging a lot of this built-in AI functionality. AI functionality with R and Python embedded right into the database. So moving away from SQL Server, right, we have to start thinking about what are some other data services that come into play when we start thinking about this large big data landscape. So of course we talk about SQL database, but we also start bringing in other additional technologies such as Azure Cosmos DB, which is much more than a NoSQL DB, right? It's a mobile and web application friendly database as a service that's fully managed on our Azure platform, delivers consistency, fast reads and writes, schema flexibility, and the ability to scale a database up and down and on demand. Our SQL data warehouse, our MPP architecture that allows you to grow, shrink, and pause in a matter of seconds while leveraging a lot of your current tool sets that you already use in your SQL Server landscape. And then our big data offerings. Offer data management within our Azure Data Lake allows you to store any file type. Together with HD Insights allows you to essentially process a lot of those big data type of workloads on top of your data set already landed, while also giving you a industry-leading class SLA. So we've talked about what it looks like from our on-prem scenario, SQL Server. We've talked a little bit about our Azure Data Services and really kind of blending those two right into our hybrid approach. There are instances where we want to take advantage of having our on-prem data sets, but also landing those in a one central store where we can do all of our heavy lifting and our analytic processing on top, which kind of leads us into our hybrid scenario. So what does this look like from a 1,000-foot view? This is kind of our big data and advanced analytics landscape, right? We talk about from ingestion to serve. We have multiple services that get brought into the fold that allow you to do ingestion processing, batch processing from Azure Data Factory. Talked a little bit about our analytics stores being the Azure Data Lake, as well as our blob stores. Stream analytics allows us to do kind of in-stream data transformations and land those for consumption. And then model and serve, right? Very, very repeatable concepts where we have our NoSQL data stores, we have our relational stores in a data mart, analysis services that ultimately feed actionable, intelligent insights to your consumers. So we've talked about kind of the services that help you get the data in. Right? Now moving on, we find that in this data movement process, the most expensive kind of fall under these three different pillars. Preparation, assembling and cleansing your data, profiling it where it makes sense specifically to your use case. Moving on to that, we go into model, right? This is where we start bringing in our advanced analytics type of scenarios where we want to build algorithms specifically to build models that will run against the data sets that we're storing. And finally, the most difficult of the three is how do we operationalize, right? What are things that we need to do to make this a repeatable process? So from preparation to modeling to operationalization, we want to get to a place where our data is close to where our processing lives. So when we talk about scalability and we talk about operationalization, start thinking about a common tool set that's currently used. So introducing kind of R. So what is R for us? Well, it's not necessarily for us, but it's more on how does it relate to how our platform is specific. So R is a statistic programming language that's been used since the early days of advanced analytics, roughly around, I think, 2000, where it was ultimately maintained by the R Foundation. So R directly supports complex data manipulation operations, and that in itself is very, very powerful tool. It has a community of over 2.5 million users. It's commonly taught in a lot of the universities as well as graduate students. And ultimately, part of that kind of ecosystem brings into this large kind of shared workspace. So there's scalable algorithms, there's open availability CRAN that ultimately allows you to kind of go search these glossaries. So CRAN ultimately leads us to kind of the comprehensive R archive network, which is an open source community that allows you to download prepackaged algorithms so that you can leverage into your own model that you want to prepare for your specific data set. So now that we've talked about the data landscape, talked about some of the data services and what kind of progressed us to the point where R became a very popular choice, as mentioned before, we get into SQL Server. And in SQL Server 2017, we have introduction of R. Well, 2016, but 2017, we bring in additional packages, no memory limits. And what I mean by that is when you build a particular model through R, you're leveraging the very powerful engine capabilities within SQL Server so you can essentially multi-process these types of packages, which becomes very powerful. So as you go through your data exploration, you want to go through your data preparation, you want to leverage packages that can scale and they can scale appropriately within your platform. So now that we've kind of blended the two, so when we start thinking about the modern approach of doing advanced analytics, we want to blend two types of scenarios together. Typically, you have a data science engineer, and then you also have a DBA. So this is where those capabilities are blending together, right? As an R user, I have the capability of being able to do all of my transformations, doing my model creations that I typically would do within my native type of IDE services. So I have a particular landscape that I like to build my code in. That code can then be replicated and moved on to SQL Server, which then brings into what can SQL Server users perform? Well, they can run those R scripts and they can run those particular modeling algorithms on top of the close data set. I think that's where we get the very powerful features of the sense that I can run my modeling techniques close to my data set. So bringing all of these kind of modeling techniques I wanted to give us kind of a glimpse of what does that actually look like. We talked about operationalization being, the most difficult part of kind of this advanced journey. And I had a quick demonstration, fraud detection demo, leveraging SQL Server in R. So in respect of time, I do have a link towards the end of this webinar that will reference the actual downloadable demo. So if you are interested in downloading the demo, you can follow the steps, very easily deploy this into Azure, and it kind of works through the process of deploying a data set and then ultimately having a BI consumption. But at a very high level, I wanted to walk through kind of this demo workflow. So within this demonstration, you have your data preparation. So this is where your data science engineer leverages their current tool sets, being maybe R Studio, and they will build that R package. And what they'll then do is step 2, they'll operationalize that model. And what that means to us is they'll take what they've created in their IDE, and they'll actually build that into SQL Server. Now, what they'll do is they'll embed that code into a stored procedure that then can be used as a query or as a function or called within an application. The deploy and visualize is geared towards your data analyst, where they can review all of the scores specific to this type of fraud detection, and then ultimately using this model in online transactions. This is where your operationalization takes the next step in, is where you start building kind of intelligent applications. So for this fraud detection example, a particular purchaser will go through a retail website, and as they're going through their purchase, they hit the purchase button. Well, on the back end, we have a particular function that then calls this particular algorithm that's been trained, or excuse me, this model that's been trained, and ultimately gives a recommendation that either the purchase goes through or it goes through an escalation of whether or not this actual transaction should get authorized. So very powerful in the sense that you can embed that type of machine learning, deep learning algorithms into your application. So now that we've kind of talked through this workflow, what does that actually look like within SQL Server? So this is a quick snapshot of one of the store procedures. And as you can see within the store procedure, you have your T-SQL syntax. And then if you follow that down, you can actually see in red here where we've defined some of the R scripting. So what we're essentially doing here is we're embedding T-SQL with R in the same landscape and ultimately packaging this up in a stored procedure that can then be called within an application or called within a different process. Outside of the actual procedure, this is the output. So now that we're talking about SQL Server and running R, we create specific scoring tables. We create specific tables that meet the demands of what you're ultimately trying to accomplish. So in this case, we created tables to essentially score particular purchases made by purchasees for specific accounts, and this gives us an interactive BI experience to drill down into those transactions. So as you can see, this allows you to ultimately understand where my transactions are coming from. So from a business analyst perspective, it allows you to drill down deeper into your data sets that gives you the appropriate insights needed to make some actionable decisions. And with that, I leave it to Michelle, back to you.
Fantastic. Ahmed, that was a great overview and some really powerful examples of how to put it into use. Having everything integrated in one place definitely simplifies customers' lives. So why is ScaleArc here today? What are we doing with Microsoft, and how do we make it easier for you to tap into the power of modern SQL? Well, we've partnered because our software acts as an abstraction layer between your application tier and your data tier. And so instead of having your apps directly talk to the database, you get a bunch of advantages when you run your apps through ScaleArc and talk to your database. So we have partnered with Microsoft because having our software in the middle enables a bunch of advantages. You can adopt modern SQL, for example, with no application code changes. You typically need to go in and program read intent strings into your app to be able to have your applications talk to or send read traffic to your replicas, your secondaries. With ScaleArc, we automatically understand reads versus writes and can direct them and load balance them appropriately so that you don't have to refactor your app to use those read intents or those read-only replicas. Similarly, this can help you get into Azure faster. You know, I think Ahmed's examples about how people are leveraging the cloud for big data are really powerful. We're seeing that as well. And one of the big barriers to getting into the cloud, any cloud, is whether your app's ready for it. And the fact that you can do that scale out, talk to multiple smaller VMs with no code changes is also really powerful. And then once you're in run mode, you're on Modern SQL, you're in Azure, the ScaleArc layer of software enables you to achieve continuous availability. And I'll step through that in a little bit more detail, but essentially, because this layer is sitting in between, it acts like a buffer for the application. So the app is not interrupted by changes at the database tier. I'll show you that in a minute. And then also, we have the ability with our connection management and caching tier to also have application transparent performance improvement. So you don't have to code caching into the app or recode on connection management. We're going to make that a lot more seamless as well. So I'll show you a few examples of how people are leveraging ScaleArc, particularly along with SQL Server. So lots and lots of cloud stuff, right? So getting into the cloud faster, building new apps in the cloud faster, and then even enhancing DBaaS, right? So we touched on some Azure Data Services today, but ScaleArc also supports Azure SQL DB. And the ability for your app to leverage that database without code changes makes it much easier to adopt DBaaS and simplify your operations. We talked a little bit about the achieving continuous availability. We're seeing that a few ways in the data center and then also across data centers. We see more and more people looking to adopt active-active architectures where resources are active in both data centers. That's really hard to build at the app tier, and ScaleArc makes that a lot easier. We touched on increasing app performance. We touched on the scale out with no code changes. And finally, this whole macro trend we're seeing where you can get onto Modern SQL a lot faster by pairing ScaleArc with SQL Server. So let me take you through one example of kind of a packet flow visual to show how ScaleArc works in operations. So first off, our ability to do read-write split is really powerful, right? So we're directing writes to the primary, some reads there as well, and load balancing the rest of the reads across all the secondaries. I'm showing this all in one location, but it could be straddling multiple data centers, or it could be straddling data center and cloud, or multiple cloud regions. So we're doing the read-write split. Let's say something happens to the primary and it's knocked offline. We recognize that that primary is not available. We actually see it faster than the AGL, the availability group listener, and we start immediately queuing any transactions that depend on the primary. So any writes and any reads that must follow those writes. We queue that right away. We keep sending the reads to the unaffected secondaries. We know which server is going to be promoted. We wait for it to be ready, and when we see that it is ready and it's becoming the new primary, then we drain our queue in a FIFO manner so that your transactional integrity is preserved. And the real power of this is that SQL Server is doing the replication, SQL Server is doing the failover, but what ScaleArc is doing is preventing the app from seeing that interruption. So rather than having the app drop all its connections and have to restart all that, they see a little delay. The writes see a little delay, but the apps don't get a whole bunch of errors. They don't hang, they don't have to be restarted. So it's a much more seamless process. And you can imagine the same capabilities, you can invoke them manually, and in this way do a series of rolling upgrades where you're able to do patches, maintenance, whatever you need to do on your database servers and not have that create downtime at the application tier. We'll route around the server that you mark offline, and then we'll bring it back into the cluster and start sending to it again. So we've done this kind of setup for a number of customers, which I'll talk to you about in a minute. But one of the more interesting is actually Microsoft IT. So the community website, answers.microsoft.com, it needed to do an upgrade. Microsoft IT had a project called Get Current, Stay Current, where they needed to be on more current versions of server technology as well as SQL Server technology. They leveraged ScaleArc to make that transition a lot faster. So a project that was originally estimated to take 18 months, the business ended up giving them 9 months to do it, and leveraging ScaleArc, they got it done in 4 months, and they got a much better outcome. We could load balance the traffic between Europe and Asia or US East, and we could do that load balancing dynamically. understanding which servers were going to respond faster, which servers had the replication in order, and it overall provided a much better, faster experience for customers hitting that community website. Lots of folks across lots of industries are leveraging ScaleArc in conjunction with SQL Server. Ahmed touched on the kinds of industries that are ahead of others in leveraging big data. We're seeing a similar thing in terms of the kinds of industries where they're just architecting for zero downtime, right? They're just building for continuous availability and pulling in the ScaleArc layer paired with SQL Server to enable that zero downtime environment. So that's a quick snapshot on how ScaleArc can help you take advantage of SQL Server's many powerful capabilities. And Ahmed, I think you wanted to chat through a little bit the resources people can go link to.
Yeah, thank you very much for that, Michelle. So as mentioned during the talking points, I just wanted to reference back to a few links that I found were very helpful. So if you are getting started with machine learning in SQL Server, I went ahead and added that link there that takes you straight to the docs. It talks about the capabilities within SQL Server in relation to machine learning. Very, very good walkthroughs. Our fraud detection with SQL Server is one of our solutions that is available through our Cortana solution gallery. So I actually have both links there. The fraud detection specifically goes straight to SQL Server where you can deploy the full suite offering. And the Cortana Solution Gallery is I find a very fantastic resource if you are looking to look at pre-built type of scenarios where you want to leverage some of the advanced capabilities that we have and leverage a lot of the community experience. Solution Gallery is where to go. And what's really great about that is you can definitely leverage a lot of what we've discussed here today. And then ultimately the Azure Solution Overview, I just put a link on there to our Azure service. So I know that we talked about a lot of our data services and kind of our hybrid scenarios. I think it's important to understand kind of the general landscape. So that link will get you there.
That's great. And ScaleArc as well is on the Azure Marketplace and again supports SQL Server or Azure SQL DB amongst other Azure data services. So with that, Ahmed, I want to thank you so much for joining us today for this presentation on data transformation and leveraging AI. Really appreciate the discussion.
Yeah, thank you for having me.
All right, and we will see you guys online on future events, and we have a whole series that we're doing with Microsoft. So the link that got you this registration, you can find 4 or 5 other webinars as well to learn more about the integration of data services and ScaleArc. Thank you so much, everybody, for tuning in. Take care.